Hey, welcome today to lesson 1.3 of thermal energy, temperature, and motion. I wore my molecule shirt today specifically for this lesson because we're going to be talking a little bit about molecules. I attached to this lesson also the food coloring temperature video thing. I made one for you, and it's so exciting. I mean, talk about blockbuster material. Anyway, that's attached to this lesson. It's on my YouTube channel as well. You can go check that out. Hey, let's jump right into this. So let's look at the warm-up together. What does it say? Students explore the features of the thermal energy simulation. 10 minutes. Whoa, 10 minutes? I don't think so. It's not going to take you that long. Exploring the thermal energy simulation. Launch the thermal energy simulation. You can just click right there on that link if you want. You can also, remember, go up to the menu here and scroll down to the thermal energy simulation. Either way, it's up to you. Explore the simulation on your own digital device. Ooh. I think they mean computer. Investigate how the simulation works and what you can change. Really, all they want you to do right here is explore and play with the simulation. I have it open right here. This is what it looks like when you open it up. One of the first things you really need to do is click Add Sample, or else nothing is going to happen. So you can click, as you can see, small, medium, or large. I'm going to go ahead and just start off with a small sample. Confirm. Ooh, look at all this. Now there's all sorts of things going on. All right, first thing I want to do is just start clicking buttons. No, actually, I kind of want to read some things first. View kinetic energy. Okay, I don't know what that means. View energy transfer. Don't know what that means. Looks like I have a time thing here. Looks like I have a pause button. I can make time go faster. I always like that sometimes. And I have this reset button, it looks like. But also here, I have this sample in front of me, sample A. It looks like I have a measurement of thermal energy. And kJ, what is that, kilojoules? It looks like I have temperature also in degrees Celsius. I got these plus and minus buttons here. I wonder what they, I can click on those. Hey, what I want you to do is I want you to play around with this a little bit, and then we're going to answer a couple questions. So do that and then come on back to me. All right, so here's the questions that we have. What are some of the things that you can do in the run mode? And as we saw, you can add samples. You can increase the temperature by clicking on this plus button. You can decrease the temperature by clicking on that minus button. You can add more samples. I'm going to add another medium sample. Look at that. If you click on this kinetic energy, view kinetic energy toggle, it shows you, here's your scale, that high kinetic energy is represented by this bright yellow, low kinetic energy is represented by this darker color. So let's see, look at that. When I click plus, it gets brighter. When I click minus, it gets darker. What does that tell me about the kinetic energy, I wonder? Anyway, okay, that's great. View energy transfer, I guess I can do stuff with that. Oh, look at that. That showed that, I guess that's showing that energy is being added to my sample or energy is leaving my sample. Okay, cool. What about the Analyze tab? Well, if we click on the Analyze tab, it shows my samples, sample A in this purplish color, sample B in this non-purplish color. And look, this is when I was like messing with the temperatures and adding and taking away energy from my sample. Cool. There's actually quite a bit of information here, quite a bit of data for us to look at. You can even add more samples if you want. So that's pretty cool. And if you want to start all over, you can reset. Not bad at all. Hey, let's take a look at number 2 in this lesson. Simulating hot and cold water. We're going to be using the simulation basically to model what we saw with the hot and cold water in the food coloring experiment. So take a look at this. This looks like our sample, right? What are all these shaky little circles? What are they? Well, let me go ahead and give it away. Some of you already answered this question, and you know they're molecules, okay? That's what they're representing. What is a molecule? A molecule is a group of atoms joined together in a particular way. Cool. Hey, look, it's everyone's favorite molecule, water, H2O. You are probably familiar with water being called H2O. Well, what does that actually mean? Well, the H, that stands for hydrogen. The 2, that lets us know that there's 2 hydrogen atoms in this molecule. And the O, that stands for oxygen. Now, there's only 1 oxygen atom in this water molecule, but you don't need to write a 1. It's just understood that there's only 1. Hey, what's another molecule that we've heard of, talked about in this way? What about carbon dioxide, right? What is the chemical formula for carbon dioxide? If H2O is water, carbon dioxide, oh yeah, CO2, right? So if it's CO2, that means that what does the C stand for? That's carbon. And there's no number after it, so that must mean there's 1 carbon atom. And the O, we know O stands for oxygen. And CO2, that means there's 2 oxygens. So there's 1 carbon and 2 oxygens in a CO2 molecule. What do you know? Learn something sometimes. Let's click on number 3. We're actually going to now go into the simulation, and we're going to represent the hot and cold water. And let's make sure we follow the instructions. Use the thermal energy simulation to recreate a similar situation to the cups of water from the food coloring investigation in the previous lesson. My water was not 70 degrees and 10 degrees. I don't know exactly how hot or cold my water was. I just know that one was just finished boiling, and the other one I had pulled out of the refrigerator. So there was quite a significant temperature difference between mine. Open the simulation. Some of you already have it open. Great. Add 2 same-sized samples. That's key. Make sure they're the same size. Make 1 sample hot and 1 sample cold. We showed how to do that, hitting the plus and minus sign under the sample. Observe the differences in the 2 samples. All right, so you go do that. And then I want you to answer these questions. What do you notice about the movement of the molecules of the 2 samples? And then explain what you discovered from the simulation about why food coloring spreads faster in warmer water. I'm going to give you take as long as you need to go do that, but then answer these questions and come back to me. All right. What did you put for these responses? What do you notice about the movement of the molecules of the 2 samples? What we should have noticed was, hey, let's go ahead and do it. I'm going to use 2 medium samples right here. I'm going to make one really, really cold as I can get it. And I'm going to make the other one as hot as I can get it. Ooh, it's taking a while. There we go. So what do you notice about the movement of the molecules? Well, I hope that it's clear that the molecules in the warmer sample are moving much faster than the molecules in the cooler sample. And that's something that you could just put right there for that response. Explain what you discovered from the simulation about why food coloring spreads faster in warmer water. Well, let's take a look and let's imagine. If I take my bottle of food coloring and I put 2 drops into sample A, and then I put 2 drops into sample B, which one do you think will mix faster? And if you said sample B, well, we already saw that. It mixes faster in the hot water. Well, can we explain now why that works? Because the molecules in the hotter water are moving so much faster and so much more vigorously that it mixes that food coloring much faster into the sample. Whereas in the colder water, those molecules are not moving very fast. And so it's going to take a lot longer to actually get that food coloring mixed in well. All right, let's go back to Amplify. Let's click on number 3, the reflection. Let's see what it says. Students reflect on what they have learned over the last 2 lessons. Reflecting on the simulation, look at the key and 4 images below. Answer the reflection question and explain your response. Here is our key: molecule speed, low and high. Hey, that was kind of like the simulation, wasn't it? If we had kinetic energy, low kinetic energy, high kinetic energy, I think that relates to the speed. And, okay, we have 4 samples here, 4 examples, A, B, C, and D. Which image shows the difference between the speed of molecules in hot and cold water? Which of these best shows the difference in the speed of the molecules in hot and cold water? And explain your answer choice. You're going to do that. I'm going to let you do that. I'm not going to answer that for you. But let me go ahead and point out the homework as well. The homework, you are doing a reading about absolute zero, and you're going to answer a couple questions after your reading. What is absolute zero? Sounds mysterious. Well, it's kind of cool. So do this reading, answer those questions, and then after that, hey, you are all done. We will see you next time.